will not just. Okay, so let's start the class. So the experience we just shared is relating to the topic that we want to treat, which is learning curve theory. Note that there's a difference between learning curve theory and then learning curve. Okay, there's a difference between the two. So what is learning curve? The learning curve is just a curve that shows the difference between the experience gained on the job through learning, okay, and how
Yes, it's connecting. It's talking out now.
Diva Glow. You guys should be very careful. You are distracting my class. I don't like it. Priska. Simple instruction. Mute yourself. If you are just immediately you join the class, just mute. You don't have to distract the class. I don't like it. Please. So like I was trying to say, there's difference between learning curve and learning curve theory. Learning curve represents the curve that shows the relationship between the experience gained on the job through learning and how the learning has resulted in enhanced proficiency, okay? So it is believed that human beings, unlike machines, will become dexterous on the job, all right? We become dexterous on the job, we become skillful as a result of our past experience. You know, confidence is a function of experience, okay? So it is experience that will build the confidence. So because you have been doing the work over and over again, a repetitive task, it is expected that you would have gained a lot of experience on the job. You become skillful and dexterous, all right? You become proficient in performing your task. So that is basically learning curve. That is a curve that shows the relationship between the experience gained on the job and how the learning has resulted to a high level of proficiency. Now, learning curve theory is the theory that assumes that whenever a repetitive task is being performed, the average time spent in producing a particular unit of that product will fall by a specific percentage when the activity level is doubled. Of course, the theory is based on the assumption that human beings, unlike machine, gain experience. I've said it, skills, dexterity, and become specialized for performing a repetitive task. And that's why in your present place of work, you know the terrain, you know which route to pass to get to your office. Even at home, because you're already familiar with the home environment. In fact, you can even close your eyes and walk through to your bedroom because you know the route, you know the path that will take you to there, that will take you there. And it's because of your experience in that environment. So it's the same thing we are saying here. So it is believed that based on the past experience, the level of experience that we have gained, so we are going to become dexterous on the job. And then the tasks that you are performing before, say for example, you are spending 100 hours to perform the task. Because of the experience you have gained, that 100 hours may decline by 20%. That means you have gained 20%. It means that you are supposed to apply 80% on the job. So your experience, the experience gain is 20%. Okay? So this is learning curve theory that we want to talk about. How can we apply this into our daily activities, into our daily task? All right? Yes. You may be asked, examiner can ask you to define learning effects, learning rates, learning curve, or learning curve theory. And that's why it is important to know all of them. What do you mean by learning effects? The learning effects occurs when the workforce learns experience from the previous job on how to make a new product. So the reduction in the time required to make an extra unit, of course, may be the learning effect. So the learning effect will result from the improvements in efficiency through experience, that is proficiency. It also applies to situation whereby workforce improve in efficiency with experience. So if you are able to gain, if you are able to crash down the time you spend to produce, to perform a particular task, that means learning effect has been applied. That's interpretation, all right? However, when the employee has acquired sufficient experience on the job, there will be nothing more to learn, and so the learning experience will then stop. Okay, you have gained everything, and that's why you see some employees, because they're already tired of the work environment, they just say, okay, I'm no more interested. What else for me? I've gained, I've learned whatever I need to learn. I think I have to move on because there's no more motivation, nothing to learn again. So this is what this is saying. So because you have acquired sufficient experience on the job, there will be nothing more to learn. And so learning process will then stop. As a result, a steady rate will be reached when the average time taken to produce an extra unit becomes constant or flat. It will not increase again. Okay, so it will not reduce. So it will just become flat as a result of that, because there's nothing you are gaining, you are not learning anything again. So that is learning effects. The learning rates, the learning curve rates, of course, is usually expressed as a percentage. Say, for example, if you are given, if you are told that an average time taken to perform a task will fall by 25%, it means that 75% will be applied in the labor force. If you are told that the average time taken to perform a task will fall by 20%, it means that you are supposed to apply 80% to perform the task. All right, on and on like that. So that is the learning curve rate is the percentage that will be applied on labor force. Okay. Now, what are the uses of learning curve effects? In what areas can you apply learning curve effects? Number one is for investment appraisal. And in any task that requires labor efficiency, that require labor hour, for example, you can apply learning curve effects. So when a company wants to evaluate a project, you are going to need material, you need labor, okay, you need overheads and other expenses, other direct expenses. So because there is labor, then of course the learning curve effect can be applied in project evaluation, which is investment appraisal. Not only that, when a company is preparing standard costs for control purposes, you can also apply learning curve effect, because you are going to need labor, you need material, you need labor when you are determining your standard costs. Number three, to establish a realistic and workable incentive scheme for workers. Again, workers are involved, so labor hours will be required. To determine marginal or incremental cost of making additional units of a product. Under the marginal cost, you also have labor. When you talk about marginal cost, it's the same thing as direct cost. What marginal cost is the extra we are talking about, the extra labor cost that will be incurred in making additional unit of a product. Again, you can use learning curve effects to do this. If a company wants to quote selling price for a contract, usually where prices are based on cost plus percentage for markup, all right? So in this case, you also need the learning curve effects, all right? So these are some of the areas in which you can apply learning curve effects. Now, for learning curve, for learning curve effect to be useful, the following condition must be present. Okay, for the learning curve to work effectively and to be useful, the following condition must be present. Number one condition is that the employees must be encouraged and motivated to learn. You know, when you are new in a job, certainly you have to learn new things. So the work environments may be so conducive for you and to enhance your innovative and then creative ability. So it is expected that the work environments will be so conducive that will enable the workforce or the employees to feel motivated and encouraged to perform the task. So if the environment is not conducive, it will be inimical to learning, and then employee will not be able to gain much. Then number two, there must be a steady work environment such that employee turnover is at a minimum. What this is saying is that when you talk about employee turnover, the employee turnover is when employees, whether through resignation, retirement, or retrenchments, leave unemployment. Okay, so we are saying that for learning curve effects to work effectively, the work environment must be stable. No employee is leaving. There's nothing like employee leaving. All right, so that's what that condition is talking about. Number three, the work activity must be labor intensive and repetitive in nature. All right, you are not using machine. What you are using is labor to perform the task, which requires labor hour. And then the task that you are performing must be repetitive in nature, something you are doing almost on a daily basis. So it's repetitive. So because if the job is not repetitive and it's not labor intensive, then there is nothing like learning curve. Number four, there must be no change in production patterns and techniques. The mode of production will remain constant. The techniques that you use for production will remain constant. Method of technology is the same, it's not changing. Then number five, this is very important. For learning curve to be effective, there must be no break. There must be no break, because once there is break, the learning effect will be lost. Okay? What this is simply saying is that the task must be continuous. The task must be continuous. It's not, you can't have a break. For some of us that are, maybe you've had the opportunity in the past to go on a long vacation, or you have a long break in the office, maybe due to one reason or the other, or if you're a woman, maybe during the pregnancy, then you now took a longer maternity leave from the office, about 6 months or thereabout. Even if you go for 1 month or 3 months, by the time you come back to that position, you will struggle again to pick up from where you left it. It will look as if you have not done that job before. And of course, because you already have the experience, it won't take you long for you to recover. But what this condition is saying is that once there is a long break, certainly all the learning experience will be lost. So for learning curve to be effective, there must be no long break. All right, so these are all the conditions for learning curve to be effective. Please watch out, is an examinable area. It's an examinable area. I won't talk about any advantages and disadvantages. Okay, so let's go to methods of determining learning curve. In the determination of learning curve, there are basically two methods that can be used. In fact, three, but let's focus on two. Number one is tabular method, then two, algebraic method. The tabular method is suitable where the required output is within the doubling range, okay? When you are asked to determine the average time taken, the cumulative average time taken to produce a particular unit, then, of course, that required output, for you to be able to use tabular method, the required output must be in the doubling range. What do I mean by doubling range? Say, for example, you are told that the first output produced, okay, the first output produced is 100 units, okay? This 100 units, the company spent the labor hours spent to produce the labor hours spent to produce the 100 units, say, for example, is 20 hours. Okay? So the required output, you are now told to determine the cumulative hour to produce 1,000 units. Okay? Cumulative hour. You have to determine cumulative hours to produce
What happened to
10,000
your
units. Required output, say, is 10,000 units.
With your money,
Ayobamidele, you are disrupting my class. Who is Sisi Nwo? Please mute yourself. I don't know why you could be so stubborn. After all my pleas. Now, what we are saying here is that if the output in the first batch is 100 units at 20 hours, hours spent to produce the 100 hours, so to produce the 100 units is 20 hours. Then you are now told to determine the cumulative hour to produce 10,000 units. First thing first, for me to be able to use the tabular method, I must ensure that this required output is within the doubling range. So I need to ask myself, is it possible for me to double 100 to make up 10,000? In fact, 10,000 is even too much to take time. Let me say 1,000. Okay. Is it possible for me to double 100 units to make up 1,000? I need to ask. Say, for example, the first batch is 100. If I double 100, 100 will become 200. If I double 200, 200 will become 400. If I double 400, 400 will become 800. If I double 800, 800 will become 1,600. You can see that the required output of 1,000 is not within the doubling range. In this case, I cannot use the tabular method because the tabular method is only suitable where the required output is within the doubling range. Another example, say, for example, you are told that, okay, the output in the first batch, all right, the output in the first batch is still the same 100 units. However, you are now told that the required output is now 64. The required output is 6,000 or 6,400. Okay, it's 6,400. How do we do this? Let's check whether the required output of 6,400 units will be in the doubling range. So the first output is 100. I can double 100 to 200. 200 can double to 400. 400 can double to 800. 800 can double to 1,600. 1,600 can double to 3,200. 3,200 can double to 6,400. That means the 6,400 is within the doubling range. So I can use tabular method to do this. You see my examples now. So if the required output is not within the doubling range, then you cannot use the tabular method. Now, so our assumption is that the required output is within the doubling range. So as a result, what are you supposed to do? When you want to determine the cumulative hour, so you are going to create about 4 columns. To determine the cumulative hour, which is Y, okay, you are going to create about 4 columns. The first column will be the cumulative output, which is the batches, output in batches. Then, remember, we are saying that the learning curve theory is based on the assumption that when a repetitive task is being performed, the average time spent to produce a particular unit will fall by a specific percentage when the activity level is doubled. And that's why we are doubling the output. So in the first column here will be the output, okay? Cumulative output. For example, like I mentioned to you the other time in our examples, if you want to do for your required output is 3,200. Required output is 3,200. And the output in the first batch is 100. Okay, so I can double 100 to 200. 200 can double to 400. 400 can double to 800. 800 can double to 1,600. Then 1,600 can double to 3,200. So I've gotten my required output because it's within the doubling range. So I would then say, for this, our hypothetical figures, we said the first batch, the 20 hours were spent to produce the first 100 units. So that 20 hours is the average time taken to produce the first batch. So I would then come here because I want to determine the cumulative hour, which is Y. So in the first one, I won't do anything. I won't do anything on the first one. I won't do anything on the first one because I'll just put the 20 here. Next one, when I now want to apply the learning on the second output, the second output now is 200. The activity level has been doubled, but the time spent is supposed to reduce by a specific percentage. Therefore, what am I supposed to do? I will now multiply the learning rate as given to me. Say you are given a learning rate of 80%, okay? Learning rate of 80%. I'll just say 80% multiplied by the first hour, the average time spent to produce the first batch, which is 20, which means that the learning has reduced, the time spent has reduced by, if 80% of 20 should give us 16, right? Okay, you can see the time has dropped from 20 hours to 16 hours. If I now want to produce this 400, I will do the same thing. I will multiply 80% of the 16. I will say 80% multiplied by the 16. Whatever I have, I will put it there. That's how the time will continue to crash. What we are now saying is that it will get to a point whereby there will be nothing more to learn. That means the learning will become flat. Okay? The average time taking will become flat. It can't change again. You can't reduce again. So now, if I've calculated the average time taken to produce each output, for me to now get the total cumulative hour, this total cumulative hour, of course, I need to multiply it with the cumulative output. Right? That's what I say, A multiplied by B to get all these figures. Okay? It is also possible in the question, examiner may want you to determine incremental hour. So to get the incremental hour, all you need to do is just pick the value. We are saying that between this and this, what is the increment? The increment is just this minus this. Whatever it is, you put it there. Between this and this one, what is the increment? The increment will be the difference you are going to put there. So that's how to find the incremental hour. If you don't do it that way, of course, you can also go and do it separately. All right. But the bottom line is that whenever you want to determine the cumulative hour or average time taken to produce a product, if the required output is not within the doubling range, then you cannot use the tabular method. Okay, you can't use the tabular method, then you have to use the algebraic. Algebraic method is just the formula, which is y, which is y represent the cumulative hour or cost per unit. Okay, if in case you are asked to determine cumulative hour or cumulative average time taken or cost to per unit, then that is y. A is the average time taken to produce the first batch. A is the average time taken to produce the first batch. X is the required output divided by output in the first batch. For example, in our hypothetical numbers, the average time taken to produce these 100 units is the 20 hours. Okay? Then that is A. X is the required output. Required output in this case could be, depending on our analogy, so it could be the 6,000, this one that is not within the doubling range, which is 1,000. So it could be 1,000, which that is the required output, divided by the output in the first batch, which is 100. That's our X. X is the required output over output in the first batch. Then B is the log of learning rates over log of learning curve over log 2. Okay. B is the log of learning rates divided by log 2. All right. So that is that. That is how to calculate average cumulative average time taken or cost per unit. If in the question you don't have labor hour, but there is a labor cost, then it has to be cost, not hour in this case. But if in most cases it's going to be labor hour, so when you have to calculate cumulative average time taken to produce the required output, this is the formula you are going to use. And I said that in case you don't have labor hour, it is possible you may have a labor cost, and that means you are going to calculate cost. All right. So I think that's that. Now, another important information you need to understand is that it is possible that you may be asked to determine production cost. You may be asked to determine production cost. So in the determination of the production cost, it is not only labor you are going to compute for. Okay, you also need to consider the variable costs, the overhead, all the direct expenses, then plus the labor cost. However, in the determination of this production costs, only labor costs and other overhead costs that vary with labor time, okay, that vary with labor hour will reduce through labor efficiency. You don't have anything to do with labor costs, to do with overhead costs, direct expenses or direct material, provided they are not relating to labor hour. It is only when your overhead is related to labor hour, then you cannot apply the learning effect. So please watch out for that. What other things do we need to talk about? So at this point, let's have illustration. So to save time and to make it faster, let's run through this together. Yes, I need one of you to read.
A customer has asked Infinity,
okay, thank you,
Infinity Manufacturing Limited to produce a bill for the supply of 1,600 units of a product.
Sorry, tell me, take it again.
Okay. A customer has asked Infinity Manufacturing Limited to produce a bill for the supply of 1,600 units of a product. production will be in batches of 100 units. The company has estimated that the time for the first batch of 100 units will average 50 hours per unit. The company also expects that an 80% learning curve will apply to the cumulative labor hours on this contract. You are required to prepare an estimate of labor hours of fulfilling this contract. Estimate the incremental hours of extending the production run of producing an additional 1,600 units. Estimate the incremental hours of extending the production run from 1,600 to 2,000 units.
Thank you, Temilade. Yes, that is the question. In the A requirements, you are to prepare an estimate of labor hours of fulfilling these contracts. So you want to determine labor hour of producing 1,600. The required output is 1,600. So how many hours is the company going to spend to produce the 1,600? The first thing first that you need to do is to determine the cumulative hour. The cumulative hour to produce 1 unit. Once you have the cumulative hour to produce 1 unit, then you now multiply with the entire 1,600 units. So, however, in the question, to solve this question, you can either use algebraic method or you use tabular method. The required output is 1,600. The output in the first batch, we are told that production would be in the batches of 100 units. Therefore, output in the first batch is 1,600. The required output is 1,600. Therefore, can I double 100 units to make up 1,600 or 1,600? Yes, I can double 100 to 1,600. How do I do that? The first one is 100. 100 will be doubled to 200. 200 will be doubled to 400. 400 will double to 800. 800 will double to 1,600. That means I can double 100 to make up 1,600. So in this case, I can use tabular method. So let's try the tabular method and see what we are going to get. However, we are now told again that the company has estimated that the time for the first batch of 100 units will average 50 hours. This is A. This is letter A. Average time taken to produce the first batch is 50 hours. And then the company expects that an 80% learning curve will apply to the cumulative labor hour on this contract. So the learning rate is 80%. So in this case, what am I supposed to do? I will just create 4 columns, one for cumulative output, one for working for calculating average time taken, then one for total hours, total cumulative hours. So let's go through this together. Now, like I said, for the cumulative output, I will go to the question, the first batch, we have identified that this first batch of 100 can be doubled to 200. 200 can double to 400. 400 can double to 800, then 800 to 1,600. I will go back to the question. I want to determine the average time taken to produce. I will go to the question. The average time taken to produce the first batch, we are told is 50 hours. This 50 hours per unit is the average time taken to produce the 100 units. Therefore, the learning rates will not apply on the 100 because that 50 is the base. So you don't need to apply learning rate on that. That is the 50 you have there. So this 100 units of the first year, sorry, of the first output produced was produced at 50 average time of 50 hours. So to now get the total cumulative hours, I need to multiply 100 multiplied by 50 will give me 5,000. I will move to the next one. I can double 100 to 200. Because the average time taken to produce the first one is 50, an examiner has given us 80% learning rates. it means that for me to be able to double it, then it means that the time I'm going to spend will reduce by a specific percentage. And that's why we said that learning curve theory is premised on the assumption that when a repetitive task is being performed, the average time spent to produce a product or a unit will fall by a specific percentage when the activity level has doubled. Now we have doubled the 100 to 200. So it is expected that the 50 hours will also fall by 80%. Sorry, will fall by 20%, which means we are supposed to apply 80%. So 80% of 50 will give us 40. 40 multiplied by 200 will give us 8,000. That's the total cumulative hour that will be spent. If you don't do it step by step like this, you can't just, our focus is on the 1,600 or 1,600. There's no way you are going to get to that 1,600 if you don't follow it step by step like that. So we have not reached the destination. The destination is to produce 1,600. Therefore, I want to double 200 to 400. Now that I've doubled 200 to 400, the average time taken to produce the 200 is 40 hours. So this 40 hours will fall by 20%. So I need to apply 80% on it. That is what gives us 32 hours. So to now get the total cumulative hours, 400 multiplied by 32 will give us 12,800. We are here to get to the destination. I can double 400 to 800. So the average time taken to produce 400 is 32. This 32 will fall by 20%. So I will apply 80% on 32. That's what produced 25.6. 25.6 multiplied by 800 will give us 2480. I can double 800 to 1,600, which is the required output. Therefore, once I do this, the 25.6 will also fall by 20%, then I will apply 80% on it. So 80% on that will give us 20.48. This 20.48 multiplied by 1,600 will give us 32,768. Therefore, the total hours required to fulfill the contract of producing 1,600 is 32,768. That is, this one is the required, that is the hour required to fulfill the contract of producing 1,600 units. So if I don't want to use tabular method, like I told you, the algebraic method can be used for anyone, whether it is within the doubling range or not within the doubling range. You can use the formula of y equal to a multiplied by x raised to power b. I can use it to do anything. So let's use the algebraic and see what we are going to get. Of course, as you know, the y represents the cumulative average time or cost per unit. Okay, cumulative average time or cost per unit, depending on the what the information you have in the question. Then the A of the formula represents the average time taken or average cost to produce the first batch. In this case, the first batch is 50. First batch is 50. Okay. Then X is the required output divided by the output in the first batch. The required output is 1,600. Okay. 1,600 is the required output. Output in the first batch is 100. So that will be 16. Okay. That's the 16 we have here. Then B is the log of learning rates over log 2. I will then go to the question. Examiner has given us learning rates to be 80%. 80% is the same thing as 0.8. So I'll go to my calculator. I'll just press 0.8. Then I'll press log, the log button on your calculator. So it will give you minus 0.0969. So again, just press 0.8, then you touch the button of log on your calculator, you get the answer. You can try it now. Then log 2 is the same thing. 2, then log, press the log button. It will give you 0.3010. So when you divide it, it will give you minus 0.329. Okay? Now, Since I've gotten all the relevant variables, I need to apply it into the formula. Okay. A is the average time taken to produce the first batch, which is 50, multiplied by the required output over output in the first batch, which is 16, raised to power log of learning rate over log 2, which is minus 0.3219. When you now, of course, use your calculator, the final answer, the average time taken, the cumulative average time taken to produce the 1600, okay, time taken to produce the 1600 per unit, okay, is 20.48 hours per unit, which is the same thing as what you have here in the table. Okay, it's the same thing as what you have in the table. Then to now get the total hours, just multiply the average hours of 20.48 with the required output of 1600. So that's what produced the 32,768 hours. So this is what you need to do. Whether you use the formula or you use the tabular method, you are going to get the same answer. Martha, please mute.
Hello, sir.
Yes.
Okay, sir. What you are saying in essence is that if the variables given cannot be doubled, that is when we can apply the algebra something, right?
The algebraic formula can be used for anyone, whether it is within the doubling range or not within the doubling range. So you can apply formula for anyone, but the tabular method cannot be used if the required output is not within the doubling range. If you cannot double the required output, then of course, it's not, I mean, you cannot use tabular. You have to use algebraic.
Okay, sir. Thank you, sir.
You're welcome. So let's move to the B part of the question. In the B part, you are required to estimate the incremental hours of extending the production run of producing an additional 1600. You know, in the first requirements, you have to produce the average, the total hours required to produce 1600. Now you want to, examiner is asking you to produce additional 1600. So 16 plus 16, that's 3,200 units. Therefore, is it possible for you to double 1600 to 3,200? Yes. So all I need to do now, based on the initial calculation from this table, I can double 1600 to make up 3,200. Okay, let me see if I have it down there. Okay, yes, I have it there. So all I need to do is to just increase it to 3,200. We have done it up to 1600. Okay, we have done it up to 1600. So I want to double 1600 to 3200. So when I double to 3200, then the 20.48 hours for the 1600 will fall by 20%. So I have to apply 80% learning. So when you apply the 80% learning, that's 16.384. So the total cumulative hour will then be 16.84 multiplied by 3,200. That's what produced the 52,429. You have to be very careful. Examiner did not, if you look at the second requirement, when you look at the second requirement, examiner did not ask you to determine the total hours required to produce 3,200 or to produce additional 1,600. No, examiner is asking you to determine the incremental hours of extending the production run from 1,600 to additional 600, from 1,600 to 3,200. So what you need to do now is to compute the hours. I'm coming, I saw your hand, Jennifer, just hold on. Now, to get the incremental hours of increasing from 1,600 to 3,200, I have two options. I can either use this table as it is. All I need to do is to create additional column for incremental hours. All these ones, I'm less concerned with all of these ones. My focus is between what has changed. How many hours was the incremental hours from 32,768 to 52,429. That's what I need. All these 3,408, 7,680, 12, 7,680, I don't need it for anything. So for me to now get the incremental hours, I need to say 52,429 minus 32,768. That is what produced the 19,661. Okay, therefore, the incremental labor hours of 19,661 is required to extend the production run to produce additional 1,600. I've answered the question. So if I don't want to follow this route, I can bring it out separately to determine my incremental labor hour. To do this, I need to determine what is the labor hours required to produce the 3,200, which is 52,429. What's the hours required to produce 1,600, which is 32,768. The difference will give me 19,661 hours. That's it. So you have to be very careful. Examiner has said you should determine incremental hour, not total hour required to extend to 3,200. Yes, Jennifer, talk to me.
This
Yep.
doubling of the thing,
Yes.
how do we know that we can double like a particular unit? How do we double
You are the one that
this,
will
like,
determine
for
it.
this B now?
You are the one that will determine it. I've explained it too. In my initial examples, I said that the required output is equal to 1,000 units. Please mute. Required output is 1,000 units. I also gave you another required output to be equal to 6,400. The output in the first batch, okay? The output in the first batch is 100 units. So if you want to double, you are the one that will determine it. So you are starting from the output in the first batch. So the required output is 1,000 units. Is it possible? You need to ask yourself whether it is possible for you to double 100 to make up 1,000. And I demonstrated it. It's not possible because I cannot. If you want to double 100 to make up 1,000, you start from 100. I will double 100 to 200, 200 to 400, 400 to 800, 800 to 1,600. That means 1,000 units is not within all this range. There's no way I can double 100 to make up 1,000 units. So tabular method will not work for 1,000 units. I have to use algebraic. In the second example I gave, the required output is 1,600. Output in the first batch is 100 units. How can I double 100 to 6,400? Yes, because I can double 100 to 200, okay? 200 will double to 400, 400 will double to 600, 800 will double to 1,600, 1,600 will double to 3,200, 3,200 will double to 6,400, which means that these 100 units, I can double it to 6,400. So the 6,400 is within the doubling range. Jennifer, is it clear now?
Yes, it is. Thank you.
All right, then. You're welcome. Yes, Jide, Lola, so you raise your hand, talk to me.
Okay, sir. So this requirement number B, it says that we should determine the incremental labor hour with additional 1,600. So you've showed us how to use the first method to determine the total cumulative hour. So let's say we are now using the algebraic method now. Can we also use the formula to determine the total cumulative hour?
Yes, Nance. So just go ahead. All you need to do now is to, in this case, your required output will then be 3,200. Okay. So you now
multiply by.
Yeah.
Okay.
So I think I have it here. So let me check. Yeah. No, I did not do it. But again, let me just demonstrate it for you. So in this case, I would then say y, of course, y equal to a x raised to power b. So my Y would then be equal to the average times taken to produce the first batch is still 50, then multiply by X is the required output. Required output in this case, you want to increase to produce additional 1,600 units. So the existing one is 16 plus another 16, that's 3,200. So that means the required output is 3,200 divided by the output in the first batch. Output in the first batch is 100 units. Let me see. Is it 100? Yes, 100 units is the output in the first batch. This is 100. Then raised to power log of learning. We've already done that, which is minus 0.3219. So mathematically, just bring out your calculator. So you will say 3,200 divided by 100, which is equal to 32. So 32 raised to power 0.3219 minus equal to, I have 0.3277 whatever, then multiply by 50 equal to, that's 16.39. Okay, I have 16. Y is equal to 16.39. So I need to multiply this 16.39 by 3,200. Let me do it. Okay, per unit, hour per unit. So total hours will then be equal to 16.39 multiplied by 3,200 units. So this will give me 16.39 multiplied by 3,200 equal, that's 52,448. 52,448 hours. That's the total hours. So I will now find the difference between this and the first one. Okay. So of course, because of the difference is just due to rounding, so the second one, I'll just say the incremental now. Incremental hours, okay? Incremental hours would then be equal to 52. If you use the numbers you have in your calculator, of course, it will be much exact. Let me use, for example, let me use the number I have in the calculator. Let me redo it and see the difference. The difference will not be material, which is 32, okay, 32 raised to power 0.3219 minus equal, okay, then multiply by 50 equal, that's 16.38, whatever you have in your calculator, then multiply by the total unit of 3,200. So here it gave me 52,433.4. Okay, 52,433.4. Irrespective, the difference is due to just rounding. So 448 minus the total hours to produce the 1,600, which is 32,768. 32,768. Okay, so the difference will be 19. Let me see. 52,448 minus 32,768. That's 19,680. 19,680. So that's it. That's it. This one is 19,661. The difference is due to rounding. Yeah. So that's that. So whether you use tabular method or you use algebraic, you are expected to get the same answer.
Okay,
so is
sir.
it clear
Thank
now?
you. Yes,
You're
sir.
welcome. All right. So let's move on. Yes, Jennifer. You are raising hand.
No.
Yeah. Okay,
Okay.
remove your, put down your hand. Okay, so let's move on. Yes, number C of the requirements. We are now told that estimate the incremental hours of extending the production run from 1,600 to 2,000. Look at, examiner is asking you to estimate the incremental hours of extended production run from 1,600 to 2,000. How do you do this? You can see that 2,000 units is not within the doubling range because there's no way you can double 100 units to make up 2,000. Therefore, you cannot use tabular method. You are expected to use the algebraic method. So first thing you need to do is to compute the total hours to produce the 2,000 units. Then you now less the total hours to produce 16 hours to produce 16,000 units. So the difference will give you the incremental hours. Okay, so let's see. Number requirement C. So since 2,000 units is not within the W range, the algebraic formula will be used to calculate total hours required to produce the 2,000 units. Hence, the difference between the total labor hours for 2,000 units and 1,600 units will represent the incremental hours. So first thing first, you need to calculate the total hours required to produce 2,000 units. So to do this, just apply the formula. A is 50. All right, X, the required output is 2,000. Output in the first batch is 100. 2,000 divided by 100 will give us 20 units. Okay, then B, we've already done B, which is log of learning rates over log 2, which produce minus 0.3219. Then all I need to do now is to calculate the cumulative average time taken per unit. So fifth A is 50 multiplied by X. X is 20. Log of learning rates is minus 0.3219. So we got the average, the cumulative average time taken per unit is 19.06. So all I need to do now is to multiply this one with 2,000 units required. Mustafa, be careful. You are disrupting the class. Yes. So now that you have calculated the cumulative hour to produce the 2,000 units, so the next thing I need to do is to get the total hours, total labor hours. So I would then say the cumulative hour per unit multiplied by the required output of 2,000. That's what gave us 38,120. So difference between 38,120 and the total hours required to produce the 1,600 of 32,768. The difference is 5,352 hours. So the incremental hours of extending the production run from 1,600 to 2,000 units is 5,352 hours. That's it. That's the end of the question. So what you need to do, it's just for you to know when to use tabular method or when to use the algebraic method. If the tabular method looks so confusing for you, then you can stick to the algebraic, because the algebraic can be used for anyone, whether it's within the doubling range or not within the doubling range. So you can just master the formula, the algebraic, and then you are good to go. So let's have another illustration. So far, any question?
Sorry, sir, I have a question, sir.
Yes, talk to me.
Sir, is it possible in an exam that the examiner will ask us to use the two formula?
No.
Okay.
You're at liberty to use anyone that is more convenient for you.
All right, sir. Thank you, sir.
You're welcome. But it's important for you to master the two, depending on the scenario of the question. At times, examiner can design the scenario such that the only method that you may be able to use may be either the tabular or the algebraic formula, algebraic method. So you don't know which is which. So that's why it is important for you just know the two. It's not difficult. Take your time, master it. It's very straightforward.
Thank you, sir. Noted.
You're welcome. Then let's move on to the second illustration. Let me see. Yes, this is a good one too. Let's have this illustration number 2. Somebody should read for us, please.
Costaris. Oh, you started your okay.
Yes.
Costaris Automobile Limited is preparing a quotation for the manufacture and supply of 64 tricycles. These are to be assembled from prefabricated parts, bought specially and fitted with the firm's own interior furnishings. The job will be highly labor intensive. Projected costs and other data relevant to the quotation are given below. It is estimated that 80% and 90% learning curves will apply to the work of artisans and unskilled workers, respectively. We are required to determine the average hours per tricycle, correct to 2 decimal places of 1 hour, and the total hours required for cumulative output of 64 tricycles, correct to the nearest full hour for artisan and unskilled workers. B, compute the total cost of producing 64 tricycles. C, the prospective client on whose behalf the quotation is being prepared has suggested that 32 of the tricycles to be supplied for the forthcoming break period, with the remainder being supplies in the following year. Comment on the possible implications of this suggestion for the learning curve calculations in question A above, and suggest how many resulting problems could be addressed in the computations.
Thank you very much, Timmy. Yes, in this requirement A, you have to determine the average hours per tricycle, and then the total hours required for cumulative output of 64 tricycle for both artisan and then unskilled labor. When you look at the data given to us, we have fabricated parts, prefabricated parts, which is more like a material or component that you are going to use for the tricycle. Then, specifically, get into artisans and unskilled. So that means you are going to calculate the average time taken to produce 64 tricycle. Okay, to produce 64 tricycle for artisan as well as for unskilled labor. You do it separately because you have different learning rates. Okay, now without wasting time, I'm at liberty. I can either use tabular method or I use the algebraic method. For me to be able to use tabular method, I must ensure that the output in the first batch, the first tricycle produced, according to the question, you are told that, yes, you are told that in this case, for artisan, you are told that 120 hours for the first tricycle. The first tricycle produced, that is the first tricycle, the company spent 120 hours to produce it. So, and I want to produce 64 tricycles. Is it possible for me to double 1 to 64? Yes, I can double 1 to 64 because 1 can double to 2, 2 can double to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64. So I can use tabular method to achieve this. The required output, don't forget, is the 64 tricycles. So I'm at liberty.
Again?
What are you saying? Talk to me.
Please, can you say that again? The way you said, is it possible to double the tricycle from 1 to 64? Can you say that again, please?
It's what I have on the screen. Maybe you can see the way I've demonstrated it. I've doubled 1 to 64 now. Okay, can you see? On the screen, you can double 1 to 2, 1 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64. I can double it. I can double 1, the first batch, which is 1. I can double it to 64.
The first batch is 1. Okay.
So, yes. So, in this case, I can either use tabular method or I use algebraic. Whichever one I use, I'm going to get the same answer. So, I will do this separately for artisan. I will also do it separately for unskilled labor. So once they have the total hours required to produce the 64 for artisan and also for skilled labor, then I need to multiply for me to get the total hours. Once I have the total hours, then I will go and determine the labor, because the examiner is asking you to determine the average hours per tricycle for both skilled and artisan. You also do for total. You have to follow the specification of the examiner, where you are told correct to 2 decimal places for of 1 hour. Then, of course, the total hour required to accumulate correct to the nearest whole number. So let's do that together. So again, this is, I've already explained this here. 1 tricycle can be doubled to the required 64 tricycle. That is, I can double 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, and then 32 to 64. Hence, the average hours and total hours for 64 tricycle will be calculated as follows. I want to use the tabular method. So using the tabular method, I will first of all do for artisan. Once I'm done with artisan, I will now pick unskilled labor. Therefore, the average time taken to produce 1 tricycle is 120 hours for artisan. Look at, it's given in the question already. That's the one I showed arrow. 120 hours for the first tricycle. Okay, so in that case, I've already determined that I can double 1 to 64. So I'm starting from 1. The average hour to produce the first tricycle is 120. 120 multiplied by 1 will give me 120. I will move to the next one. I have doubled 1 to 2 now. Then, examiner has told us that the learning rate for artisan, is 80%. So if learning rate for artisan is 80%, it means that the company has gained 20% experience. Therefore, 120 multiplied by 80 will give us 96. 96 multiplied by 2, that will give us 192. I can double 2 to 4. So, to do this, the average hour to produce two tricycles is 96. So I'll apply 80% learning on that. That will give us 76.8. 76.8 multiplied by 4 will give us 307. The next, I can double 4 to 8. If I double 4 to 8, then the learning rate must fall by 20%. That means I need to apply 80%. Therefore, 76.8 multiplied by 80% will give us 61.44. 61.44 multiplied by 8 will give us 492. Don't forget, examiner has told you that you should round your number to 2 decimal places. You have to follow the specification instruction. Then the next one, I want to double 8 to 16. To do this, the learning experience has dropped by 20%. So I need to apply 80% on the 61.44. Multiplied by 80, that's 49.15. Multiplied by 16, that's 786. I've not reached the destination. Examiner is asking us 64 tricycle. That's the required output. So I can double 16 to 32. If I double 16 to 32, then I need to multiply 80% on the 49.15, which produced 39.32. 39.32 multiplied by 32. That's what gave us 1,258. 1,258. Then finally, I can double 32 to 64. If I double 32 to 64, then I will apply learning rate on the 32.39, which is 31.46. 31.46 multiplied by 64 will give us 2013. So that means the total hours required to produce the 64 tricycle is 2013. That's the 2013. I will do the same thing. I will do the same thing for unskilled labor. Follow the same route. All right, follow the same route. And we got the same thing as we got 2041. Okay, the total hours to produce the 64 tricycle for unskilled labor is 2041. So now that I have the 2041 for unskilled labor, I can then go ahead to build requirements. Remember, in requirement A, examiner only has to determine average hours per tricycle and the total hours, total cumulative hours to produce the 64 tricycle. For artisan and the skilled labor, we have done that. So in the B requirement, examiner wants us to compute the total cost of producing 64 tricycle. I will then go back to the information given to me in the table. I want to determine total cost of producing 64 tricycle. You know, when you want to determine cost, it has to be both your variable and your fixed cost. So it has to be your variable plus your fixed cost. So in this case, I need to determine the prefabricated parts. It's 3,200 per tricycle, and I want to produce 64 tricycle. That means, of course, I will multiply 3,200 multiplied by 64 tricycle. Then to get my labor cost, my direct labor cost for artisan will be 16 naira multiplied by 2013, because the total hours to produce the 64 tricycle is 2013 for artisan, then 2041 for unskilled. So I will multiply 8 by 2041. I will multiply 16 by 2013. That will give me the total labor cost. Then I will now consider direct labor related costs, 25% of the total direct labor cost. All of that, just put it on the table for this in the solution. Go there together. Yes, this is it. So we want to calculate the total cost of producing 64 tricycle. So like I said, this fabricated part is 3,200 naira per tricycle. So we want to produce 64 tricycle. Just multiply that give us a 204,800. Then I need to determine the labor cost. The direct labor cost for artisan, the total hours required to produce 64 tricycle is 2013. That's the 2020 you have here. So I'll multiply with 16 naira. Again, the total hours required to produce 64 tricycle for unskilled is 2041. So that's the 2041 you have here. When you multiply, this will give us 32,208. This will give us 16,328. Then, that's from the question, we also told that direct labor related cost is 25% of total direct labor cost. So all I need to do is to add up direct labor cost for artisan, direct labor cost for unskilled. I will add the two together, then I will multiply 20% on it. So, and then that's what gave us the 12,134 naira. Okay, then other miscellaneous costs. We are told that it's 1,000 naira per tricycle. Therefore, 1,000 multiplied by 64, that is 64,000. You add up everything. So that's what produced 329,470. So the total cost of producing 64 tricycle is 329,470. So to now get the average cost per tricycle, you need to divide the total cost of 329,470 by 64 tricycle. So that's what produced 5,148 naira. So that's the unit cost per tricycle, 5,148 naira.
Sorry, sir. Please come again on the average cost per tricycle.
I said the average cost per tricycle is total cost of 329,470 divided by 64.
Oh, okay. All right. Thank you, sir.
You are welcome. Okay. Jesse, please mute. Yes. Let's go back to the requirements. So for requirement C now, you are told that in the requirement C, you are told that the prospective clients on whose behalf the quotation is being prepared has suggested that 32 of the tricycle be supplied for the forthcoming break period, with the remainder being supplied in the following year. Comment on the possible implications of this suggestion for the learning curve calculations in A above and suggest how many resulting problems could be addressed in the computation. Remember, one of the conditions that will allow learning curve effects to be effective is that the task must be labor intensive and repetitive in nature. Not only that, the task must be continuous. There must be no break. There must be no long break, because once there is break, the learning effect will disappear. Now, in this requirement number C, examiner is telling you a client on whose behalf this tricycle is being produced is now suggesting that it should produce 32 tricycle. Now, then the remaining 32 should be deferred to the should be deferred to the following year. So you should know that the condition, once there is a break, that will affect the learning effect. So, and this is what the examiner wants you to comment on. So to save time, let's see how we treated it. Now, requirement number C, our comments. The suggestion that 32 of the tricycle be supplied for the forthcoming break period and the remainder of 32 being supplied in the following year will negate one of the underlying conditions under which the learning curve theory can work effectively. The condition states that there must be no break, there must be no long break. Otherwise, the learning effect will be lost. Therefore, the break in production process until the following year will result in loss of learning effects. Since the break may be for a lengthy period, all the experience gained through learning to produce the second batch of the 32 tricycle will be lost. Okay, so that means you have to start all over again. And that's why we are saying that the condition, one of the conditions that will make learning effect to work effectively is that there should be no long break period. Okay, that's one. The second part of the requirement says that to address the problem, now the total labor hours for artisan will be 1,258. Of course, we have to do the calculation. How do you do that? So what you need to do now is to do your calculation. You do your calculation as if you want to do, we do your calculation for 64, just like we have done the 2013 and the 2041 hours for artisan as well as for unskilled labor. Then you now do your calculation for total hours for producing 32 hours. Sorry, for producing 32 tricycle. So, and see the difference, what has changed. Okay, because if you produce 32 tricycle now, how much will the company incurred? If you produce 32, the balance of 32 in the following year, how much will the company incurred? So the total incurred when there is break and the total incurred when there is no break. What has happened to labor costs? Of course, labor costs will increase. When there is a break, it will increase labor cost. Okay, so let's see how we treated it. To address the problem, the total labor hours for artisan will be 1,258. We have computed 1,258 previously. Let's go back to our table for 32. Yes, this is the 32. Let me remove this so that it will be clearer. Now, this is the 32 here. If you produce 32 tricycle now, the total hours is 1,258 under for artisan. For unskilled, okay, if you produce 32,000 now, total hours they are going to spend is 1,134. So that's what I was trying to explain down there. Okay, an unskilled labor hour will be 1,134 for each of the 32 tricycles. That is for the produce 32 now, then the balance of 32 in the following year, as shown in the calculation above. However, because of this split, the total labor cost for artisan will increase by 25% and unskilled labor by 11%. Overall, the total labor cost increase by 20%. How did we calculate? How did we arrive at 25, 11, and then 20%? Let's do it together. For artisan, we want to determine additional labor costs that will be incurred. For artisan, labor cost per unit, labor cost per tricycle is 16 naira. To produce 32 tricycle now, you are going to spend 1,258 hours. To produce the same 32 tricycle in the following year, you spend the same hours of 1,258 hours. That's why you are seeing 2 periods there. So you now multiply 16 naira, multiply by 1258, multiply by 2. That's what gave us this 40,256. So if there is a break, if you produce 32 tricycle this year, and the remaining 32 tricycle is being produced in the following year, the total labor cost the company will incur is 40,258. However, if the company decides to produce the entire 64 tricycle now, the total labor cost that will be incurred is 32,208. How do we arrive at 32,208? We've done it before. This is the 32,208. All right.
Sorry, sir, Mr. Anijuwon.
Yes.
These two periods, how do we come about it?
Examiner told you that 32,000 should be produced now. The balance of 32 in the following years. That's 2 periods now.
Okay.
Yep.
All right.
Yeah. So the difference between the total labor cost, if there is a break of 42,256 naira, and the total labor cost, if there is no break of producing the 64 tricycle of 32,208, the difference is 80,48. That's incremental labor cost that the company will incur. What is the percentage increase? The old one is 32,208. Increment is 80,48. Therefore, 80,48 divided by 32,208 will give us increment of 25% in labor cost for artisan. You do the same thing for unskilled. For the unskilled labor, if you produce 32 tricycle now, the labor cost that will be incurred is 1134. Okay, it's 1134 for artisan. Sorry, for unskilled, 1134. Then, of course, you are producing 32 now, which is 1134. You're also producing 32 tricycle in the following year, the same 1134. That's 2 periods. Therefore, 8 naira per labor. Labor rate is 8 naira for unskilled. So 8 multiplied by 1134 multiplied by 2.
I have a question, sir.
What's your question?
You said that if they are going to produce the second batch of 32 in the next period, that it means that they'll have to start all over again. So I'm wondering why we are still using 1,134 hours in the next period.
Is it not? Hold on. It's the same thing you are going to get now. You are starting all over again. If you want to compute your average labor, average time take, is it not the same 1134 you are going to get as total? When you are starting over again, that is, you are doubling from 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32. Won't you start all over again? It's the same hours you are going to get now. No be so?
Okay.
Yeah. So 8 naira is the labor rate for unskilled, multiplied by 1134 hours, then multiply by the first 32 plus the second 32. That's 2 periods. So multiply by 2. So that is this. In this case, what this simply is just saying is that this will be 2268. That is 1134 multiplied by 2. That will give you 2268. But in any case, so the total cost that we're going to get if there is a break for the unskilled labor is 18,144 naira. Now, if there is no break at all, it will be 2041 multiplied by the labor rate of 6 naira, sorry, of 8 naira. And of course, that is what gave us this 16. We've already done it up there. We've already done it. That's a 16. You are seeing here 16, 328. All right. So in this case, the difference between the two is 1,816 naira. What's the percentage increase? If you delay, if you defer the rebalance of 32 to the following year, the unskilled labor cost will increase by 1,816 naira. That is 11%. So on the overall, what is the increment in the labor cost? If what we are trying to say in essence is that if there's a break, if there's a break in production, learning effects will be lost, because if that is the case, the company will incur additional labor cost. What this simply means is that our labor cost has increased for almost I think 9,000 something. What's the difference? 58,400 minus 48,536. That's about 9,864. Labor cost has increased by 864. That's overall 20%. So that is the question. That is the question. So that's it. That's the end of the question. Let me know. Take your time to review the material and let me know if you have any question. Let's have one additional question. That will be the end of the class. So if there is no additional question, somebody, okay, is the old one. Is this class recorded? Yes, it is. All right. So let's have one more illustration and that will be all for today.
Hello, sir.
Yes.
So what if we are to use the formula method to do this? Because I'm looking at it, I'm looking at the, when we are to get the, for X, then we divide by output in first batch. How do we apply batch in this kind of question?
It's the same thing. Just use your formula, you get the same answer. Whether you use, I've already told you, I've already done the explanation for you. Whether you use tabular method or use a formula, you are going to get the same thing. So don't confuse yourself. Let me just demonstrate one for you so that you see what I'm talking about. For the artisan, we are saying y is equal to ax raised to power b. So my A is the output, is the average time taken to produce the first batch. For artisan, examiner has told us that 120 hours will be spent to produce one tricycle. Multiply by X. X is the required output. Required output is 64. Divided by the output in the first batch. Output is in the first batch is 1. Okay, output in the first batch is 1. Then this raised to power B. B is log of learning rates over log 2. What is the learning rate for artisan? Learning rate is 80%. Therefore, log 80, log 0.8 divided by log 2 will give me minus 0.3219. Mathematically, use your calculator and get the final answer. I will say, for example, 64 raised to power 0.3219 minus equal, then multiply by 120 equal. That's 3.31.46. Here is 31.46 per unit, hour per unit. Is it not the same thing with what you have here? I've already told you, whether you use formula or you use tabular method, you are going to get the same answer.
Okay, so, thank you, sir.
You are welcome. So let's have one more illustration and we'll call it a day. Just know, Ogechi, just know both as animal. Okay, you are trying to respond to the, okay. So let's have one more illustration, and that will be all. This one is too cheap, so you can just read through. Yes, let's solve this one, Oluwalugbo, Oluwalayimo rather. Illustration number 4. Somebody should read. Who will help us?
So we have just 9 minutes remaining.
Yes. Oh yeah, somebody should read. Jessica, read.
Ololayemo Company
Jessica,
Limited.
read.
So I'm reading.
Okay, yeah.
Ololayemo Company Limited has been making annual purchases of 60,000 pumps from Water Engineering Nigeria Limited. The price has increased each year, reaching a level of 136 naira per unit last year. Because purchase price has increased significantly, Ololayemo Company Limited management has asked that an estimate be made of the cost to manufacture the pumps in its own facility. The company has no experience with products requiring assembly. The engineering, manufacturing, and accounting departments have prepared a report for management which includes the estimates shown below for an assembly run of 10,000 units. Additional production employees would be hired to manufacture the sub-assembly. However, no additional equipment, space, or supervision will be needed. The report stated that total cost of 10,000 units would be 1,114,000 191.40 per unit naira per unit. The current purchase price is 136 naira per unit, so the report recommended a continued purchase of the product. And the table below, it will be assembly labor consists of hourly production workers, factory overhead applied to products on direct labor cost basis. Variable overhead costs vary closely with direct labor cost. Fixed overhead, this is variable factory overhead, 100% of direct labor. So I can go down, please. Thank you. General and administrative overhead is applied at 10% of the total cost of material for components, assembly, labor, and factory overhead. Required, assuming an 80% learning curve, what will be the cumulative labor cost for producing the 80,000 pumps during the first year? Compute the total incremental cost for each pump produced with the 80% learning curve if 80,000 pumps are eventually produced. Then should Ololayemo Company Limited make or buy the pumps?
Thank you, Jesse. Yes, that is the question. When you look at the requirements, you will notice that this is learning curve involving make or buy decision. So in the A requirements, you have to assume an 80% learning curve. Jesse, you can mute. So you have to assume an 80% learning curve. What will be the cumulative labor cost for producing the 80,000 pumps during the first year? Look at the requirements. Cumulative labor cost of producing 80,000 pumps during the first year. So you can see here, examiner is referencing cost, not hour. In the first two that we have determined, or we have the first two illustrations that we have solved, examiner was asking us to determine cumulative labor hour. But in this one, it is cumulative labor cost. So what are you supposed to do? It's the same formula. However, of course, like I said, you can use the algebraic method for anything without wasting time. All I need to do now, I'm not using anything, I'm not doubling anything. All I need to do is to just go ahead and compute my cumulative labor cost. How am I going to do it? Just use the formula y equal to ax raised to power b, and I will get my answer. Now, but there is a challenge here, because as you know, we said y equal to ax raised to power b. A is the average cost incurred to produce the first batch. I will then go to the question, how do I determine where is the first batch given to me? Examiner has told you in the question that if you look at the first paragraph, the last statement in the first paragraph, you are told that the engineering, manufacturing, and accounting departments have prepared a report for management, which include the estimate shown below for an assembly run of 10,000 units. The units produced in the first batch is 10,000. So if the units produced in the first batch is 10,000, what is the labor cost to produce all the cost that you are seeing in this table? Is on the basis of 10,000 units. So our focus now is on the assembly. Our focus is on the assembly, assembly labor, because you want to determine the efficiency in labor. Therefore, I would then say the total labor cost of 600,000 naira divided by the output of 10,000 units. That will give me labor cost per unit. Labor cost per unit will then be 6 naira. Okay, will then be 60 naira rather. So if that is the case, once I have it done, then I then need to calculate my X. X is the required output. Required output is 80,000 pumps divided by output in the first batch. What is the output in the first batch? 10,000. Output in the first batch is 10,000. So I will say 60 multiplied by 80 raised to power log of learning rates over log 2. That's it. It's as simple as that. So let's check the answer. Again, since labor hours for first batch is not given, and because emphasis is on cost, therefore, the cumulative labor cost will be computed using the algebraic formula, just as you have it here. Y is equal to cumulative average cost per unit. A is the average cost to produce the first batch. To get the average cost to produce the first batch is 600,000 divided by 10,000 units. That's 60 naira per unit. Again, X is the required output divided by the output in the first batch. Required output is 80,000 pumps. Output in the first batch is 10,000 units. When you do the division, so you are going to get 8 units. Now, B is log of learning rate over log 2. Examiner told us to use 80%. We are told that assuming an 80% learning curve. So that means there is 20% experience that have been gained. So in this case, I will say log of 80%, which is minus 0.0990969 divided by log 2. Log 2 is 0.3010. So when you do that, of course, B is equal to minus 0.3219. Yes, IB, what are you saying?
Please, can you explain again why we use the assembly, was the assembly cost, the 600,000?
I said in the question, we're not given labor hours. There is no labor hours to produce the first batch. In the first 2 illustrations we solved, examiner gave us labor hours for the first batch. In this particular question of Olowo Layemo Company Limited, we are not given labor hours for the first batch. So that means, you know, in your formula, the Y is equal to cumulative average time or cost per unit. A is the average time or cost to produce the first batch. So since in the question, you don't have anything like labor hour, that means it has to determine, you have to determine the labor cost. So what is the cumulative average cost to produce one pump? What is the average cost to produce the first batch? So that's the essence of what we have done. And I said that we don't know the cumulative average cost to produce the first batch now, because that is the requirement. That is what you want to do. But A can be gotten from the question. To get the average cost to produce the first batch, the first pump that was produced, what is the average cost of producing the first batch? I will go to the question. The labor cost given to us in the question is 600,000 naira. This is the labor cost of 600,000 naira. The units that make up this 600,000 is 10,000 units. So 600,000 divided by 10,000, that will give us 60 naira. So that means average cost to produce the first batch is 60 naira. That's what we have here. X is the required output over output in the first batch. The required output is 80,000 pump. Okay. Output in the first batch is 10,000 units. So 80 divided by 10,000 will give us 8. You know the B, which is log of learning rates over log 2. And which, of course, that gives us minus 0.3219. That's what we have done. So it's not compulsory that all times must be labor hours. If you are not given hours in the question, then you have to calculate labor cost. Okay, so like in this case now, we are not given labor hour, and that's why we went ahead to compute for labor cost. Okay?
Yeah, thank you.
You're welcome. So to now get the cumulative average cost per unit, which is Y, I would then say A is 60, X is 8, then B is minus 0.3219. Put everything in your calculator on your calculator. We got 30 naira 72 kobo per unit. The cumulative cost per unit, the cumulative average cost per unit is 30 naira 72 kobo. To now get the cumulative average cost, of course, the cumulative total cost for the pump would then be how many pumps do you want to produce? 80,000 pumps. The average cost per pump is 30 naira 72 kobo. So when you multiply 30.72 by 80,000 pumps, that's what produce 2,457,600. That is the total labor cost of producing the 80,000 pump. That's the first requirement of the question. Then I will move to B. In the B part, you are to compute the total incremental cost for each
Hi. Oh, okay.
Hello, sir.
The class has ended though.
It's like we lost.
The class has ended or what?
And okay. Maybe it's network.
It might be network for someone. Because the sharing page has already,
Yes.
you know.
Sorry, it's my network that misbehaved.
Okay.
You're welcome, sir.
So let's quickly complete this. Let's wrap it up.
Okay.
So let me confirm if my recording is still on.
Yes.
Yeah, still on. So please mute. So in the B part, what the examiner is asked, please mute. Pyramid. Now, what the examiner is asking you in the B part of the question is that you want to determine total incremental cost. Examiner did not tell you to calculate labor cost alone. So when you say incremental total cost, so all you need to do is to consider the components that you have in the table as given to you in the question. What is the cost per pump? Cost per unit of the components. Your labor cost now is no more 600,000. Per unit is no more 60 naira, rather, it is now 30.72 because you have applied the learning effects. The factory overhead, if examiner has not explained the factory overhead, of course, factory overhead will be irrelevant. But examiner now told you that the factory overhead is divided into 50% of direct labor is for fixed factory overhead. Then the variable factory overhead is 100% of direct labor. The general and administrative overhead is supply item. So general and administrative overhead is irrelevant. We don't need it for anything. Therefore, without wasting more time, so all I need to do, I would then say for the components, the total components is 240,000 naira. So 240,000 naira divided by the activity level of 10,000 units. That is what produces the 24 naira that you have here. The assembly labor cost per unit, we've already determined that, which is equal to 30.72. That's a 30.72 here. Examiner now told you that a variable cost, the variable factory overhead is 100% of direct labor cost. And the direct labor cost is 30.72. 100% of 30.72 is the same thing as 30.72. When you add it up, the total incremental cost per pump is equal to 85 naira 44 kobo. That's it. If you want to check the working for the component and the variable, you see it down there. I've already done it. This is 24. This is 30.72 there. Finally, in the C requirements, examiner is asking you to advise whether Olowo Layema Limited, Company Limited should make or buy the pumps. So this is make or buy. In this case, you need to compare the supplier's quotation of 136 naira. Okay, the supplier's quotation is 136 naira versus relevant cost of making the pumps. Relevant cost of making the pump of 80,000 pumps is equal to 85.44. Okay, so that's what examiner is asking you. Supplier's quotation is 136. Relevant cost of making it is 85.44. There is a saving of 15 naira 56 kobo. Therefore, I will then say, in conclusion, I will say the relevant cost of making the pump is 85.44 is lower than the current purchase price of 136 naira. Therefore, Olowo Layema Company Limited should make the pumps to save 15 naira 56 kobo per pump. That's the end of the question. You must be able to think outside the box. So take your time to review the material, and yeah, that's it. That's it. Let me know if you have any question for me before we call it a day. Any question? Okay.
Hello, sir.
We are going to okay.
Yes, talk to me, Christopher.
Yes,
Hello,
sir.
sir. Good afternoon, sir.
Please, I've told you guys, if you want to talk to me, raise your hand. Don't talk randomly. That will be chaos. This one is talking, the other one is talking. Who do I answer? So raise your hand. So Adejo, you are the first person. You talk to me.
Okay, sir, please, are you going to share this material with us? Because the one we have here, there's no calculation. No calculation in it.
Of course, you are going to see the video now. You see the video recording. I will share with you almost immediately. The video recording, I will ensure the admin share it immediately. All right.
All right.
So the working notes you are seeing there, the material is the simplified ebook. So it's a proprietary book.
I understand.
Some of you have access to it, so it's not a problem today. So yes, Victoria, you were saying something. Talk to me.
Thank you, sir. You just said it. You said you will be dropping the video almost immediately.
Yes, admin will do that. No worries.
Okay,
I'm going to
okay,
share
sir.
it.
Thank you, sir.
Yes. Yes, Abdulhamid. P1.
No, I'm not asking questions. I'm just thanking you for your time.
Oh, okay. Thank you, Peter. So any other question?
If you have any question further, we'll still get back.
No problem. Yes, any other question? If not, we close the class. Okay. Yes, thank you everyone for your time and understanding. I will see you again next time by the grace of God. So thank you everyone. Bye-bye.
Thank you, sir.
Thank you, guys. See you next weekend. Bye.
Bye.